This is an example of the various technologies employed in these so-called reduced power consumption, um, energy saving or whatever incandescent halogen lamps. This is just for comparison the filament assembly out of a dead, it was broken in the case when I got it, but that's why I got the case for so cheap, case of 57 watt, 130 volt Pro-line General Electric lamps. This is the this is the assembly out of a dead Philips Halogena lamp. This is one of the I think this was one of the 43 watt ones. Don't recall, this was used in one of the lights in our kitchen, which is why there's all that darkening on what was the top end of the capsule, because it was mounted like that in operation when this lamp still worked. Fairly typical budget borosilicate glass capsule. As you can tell, it's just got your standard Kovar copper-plated nickel steel lead-in wires. Proper quartz halogen lamps like this one. This is the assembly out of one of those very expensive TB19 envelope lamps that were originally $10 a 2-pack. These, you can see in there, they've actually got a little molybdenum foil seal because the quartz has a very, very, very low coefficient of expansion, so you can't use normal metal seals. You need to use a little tiny, very thin molybdenum foil seals. Now, of course, one problem with that is that these originally had an issue with exploding. Like, for example, this lamp, which is circa 1990s, don't know exactly when it was made. The date code, or what is possibly a date code, is G110, but never seen a General Electric date code like that, so I can't date it. If any of you watching this know that, or know how to date it, say so in the comments. But this employs one technique that these early lamps needed to use, and that it's got a very, very thick glass, almost bottle, surrounding the capsule, because these often exploded at end of life. More recent advances in things like fill gas and optimization allow lamps like this, which is an Osram Sylvania 800 lumen 43 watt SuperSaver halogen lamp, to use just your standard, only a couple tens of mils thick soda lime glass envelope, because there isn't much of a risk of the lamp exploding at EOL. But that's one problem with these lamps, or ones that use this kind of a capsule. Although the advantage is that you can use just standard lamp working equipment, since the melt temperature of borosilicate glass is fairly comparable to soda lime glass, whereas with quartz you need to get the stuff, or you need to get the quartz well over 3,000 degrees Fahrenheit before it'll melt, which greatly restricts your tooling options, because there aren't a whole lot of things that remain solid at those kind of temperatures. And then this is, as I've stated before, the remains of one of those TB19 envelope SuperSaver Halogena lamps. This one was a 40 watt lamp, also 800 lumen, but this one was, I think, a rated life of about 3,000 hours or something. The advantage, this one employs a specialized halogen capsule, which has a dichroic coating on it that reflects a lot of the infrared light generated by the filament back onto it, thus increasing its temperature. So it improves the efficiency of the lamp, and it allows it to be, so it has comparable efficiencies to something like that. It's actually slightly better. It's 40 watts instead of 43 watts for the same amount of light, but while also having a greatly increased lifetime. The problem with that is that the filament has to be very rigid in order to remain in that optical center, or remain on that down the center of the lamp, because otherwise it moves out of the focus, or it moves. It interferes with the optical system in the lamp, and the filament temperature greatly decreases in these. If you shake the fixture, there's fairly pronounced flickering just from the filament cooling as it moves out of the focus of the lamp envelope. And of course, it also means that the filament's a lot more rigid, which means that these are much more sensitive to shock than our normal incandescent lamps. But these are generally okay as long as the vibration can be kept to a minimum. I know these only lasted, I think, a few hundred hours instead of the 1,000 that they're supposed to, but nowhere near as bad as the crap Indonesian Philips lamps like that one, which I think died after something like 20 hours of use. It's supposed to be a 1,000 hour lamp. But anyways.